Okay, guys, so let's continue with trig. We're gonna have two classes this week, um, Monday, Tuesday, and the concepts that we will cover this week, I don't think they're gonna be as challenging as the previous week. Um, so now the trig will look more like what you did in grade 10. But it will be a little bit more powerful in the sense that in grade 10, as you can see in the starter question, you were only able to work with right angle triangles, right? But now we are going to extend that knowledge to any triangle, okay? So, um, but it's not going to be as challenging, even though you're not going to be solving just the right angle triangles. Okay, so hopefully this week will be a little easier. Wednesday, I will have office hours, and on Thursday, I'll give you your test, which has already been made. It's just a question of now, hopefully, in Monday's conference, we can decide how to have that test done. So you'll get more information on Monday during the conference. So please make sure to attend that, right? So that's mandatory. Anyway, we'll talk more about that later. So let's start off with some review question from grade 10. So I added the right angle in there because that's a crucial piece of information. And I'm asking to find the side B, okay? Um, so, right, when we have a right triangle, Um, two things should automatically come to mind, okay? First of all, Pythagorean theorem. Now, Pythagorean theorem only works when you have um, a triangle has three sides, right? So if you know two of the sides and it's a right triangle, then you can use the Pythagorean theorem, okay? So that's the one thing that should come to mind. But I'm going to mention something else a little later, okay? So let's use the Pythagorean theorem. So that tells you that a squared plus b squared is equals to c squared. We're solving for b. I'm going to be very quick with the algebra because I'm assuming that you guys know how to do this. Okay, so b will just equals to c squared minus a squared, and then you have to take the square root of that, okay? So if we plug in our values, so this means that it's going to be 25 squared minus 15 squared, and then you take the square root of that, okay? And you guys can do this however you want. I'm just going to do this very quickly, okay? So 25 squared minus 15 squared, square root, that's 20, okay? So using the Pythagorean theorem, I was able to figure out what the third side of my triangle is, and it happens to be 20. Now, since the units are not given, let's not bother about the units, okay? So right angle triangle, Pythagorean theorem. That's the first thing that should come to mind, okay? The second thing that should come to mind is SOHCAHTOA, okay? SOHCAHTOA, okay? Now, what I'm gonna do is let's actually find this angle, okay? So let's label the angles. First of all, so if this is side length B, and we're going to talk about this a little later, then we should call this B, okay, capital B, because um, the angle, the side, small b will always be opposite to the angle B, okay? So that's something that we're going to practice a little bit later. So I think it's a nice um, idea to kind of like introduce that to you right away. So this is side C. Then this corner, this angle has to be capital C, okay? Because they have to be opposite to each other, okay? And in the same fashion, if this is small a, then this has to be capital A because this angle, this side, small a, will always be opposite to the angle. Okay, so this is how you would label a triangle. And we're going to see that shortly, I guess. Okay, so let's just figure out what angle B is. Okay, so angle B, again, here, because all three sides are given now, right? We have calculated all three sides. You could use um, sine, cos, or tan to figure that out, okay? But let's just pretend that we don't know the 20, okay? Let's just pretend that we did not do the Pythagorean theorem and we don't know that the b value here is actually 20, okay? So let's ignore that piece of information and let's just say we only had 15 and 25. Then how would you figure out what this angle is, okay? So if I have this angle, right? I know what my hypotenuse is, right? It's 25. And I also have my adjacent side. So if I have my adjacent and my hypotenuse, then that forces me to use cos, okay? So that's how SOHCAHTOA works. Okay, sine wouldn't work because sine for sine to work, um, you need to know what the hypotenuse is, which you know, but you don't know what the opposite side is, right? Because, like I said, this was calculated using the Pythagorean theorem, so we're just pretending that we haven't done that, okay? So sine wouldn't work and tan wouldn't work either because you don't know what the opposite side is, okay? So, um, as the question was posed, I guess initially, the only thing that would be possible here is to use ka, okay, which is cos. So let's just remove all this and let's work with ka. So cos of my angle. So B is my angle over here. Okay, so this is angle B. Usually you call it theta, you can call it whatever you want, but we're going to call this B because of this capital letter. Okay, so cos of B is equals to the adjacent side, which is 15. So, let's just, yeah, so car, right? So adjacent side is 15 and my hypotenuse is 25. So if I solve for angle B, right, then B will equals to um, cos inverse of 15 over 25. And this is roughly equals to, so cos inverse of 15 divided by 25. And this gives me approximately 53.13, okay? Again, I'm just using B because, but you might see angle B in the textbook, so that just means angle B. It doesn't really matter, it's just a question of notation, I guess, okay? So I'm not gonna put that there. So let's just stick with this. Okay, so B is equals to 53.13. If you're really picky, you could say angle B. Okay, so it doesn't really matter. Now, why am I doing this? Okay, so let's erase everything in here. We know that the B value is 20. Okay, now let's just pretend that, like I said, let's just pretend that we don't know that. Okay, and let's just pretend that what we know is this angle is 53.13. We know what A is and we know what C is. Can we calculate B? Okay, without using the Pythagorean theorem. Now, SOHCAHTOA works if you have an angle and one side of the triangle. In this case, it's obviously going to work because we have two sides, right? But even if we only had one side and an angle, SOHCAHTOA would work, okay? So what am I interested in? I am interested in figuring out what this side is. Okay, so let me use a different color for this. So let's just go with green. Okay, so I'm interested in figuring out what this side is. Okay, so I could use either sine because sine is opposite over hypotenuse, or I could even go with tan because tan is opposite over adjacent, okay? Either way, I will be able to calculate this side length, small b, okay? So pick your favorite trig ratio. Let's just go with tan, okay? Because usually we don't use tan a lot. So I know that tan of b is equals to the opposite side over adjacent, okay? The adjacent side, okay? So that means, so this arrow just means then. So 10, I know the angle, right? The angle is 53.13, actually, not 15. So let's just change this to 3. Okay, so 10 of 53.3 is equals to, let me just be consistent with my colors, my opposite side, which is B, divide by the adjacent side, which is 15. So if I multiply this out, right, so, if you want cross multiplication, right, this denominator is just 1. So that means 1 times B is just B. So B is just equals to 10 of 53.13 times 15. Make sure your calculator is in degree mode, okay? So 53.13 times 15. So B is equals to, as you can see, if you do this, it's 19.99999, right? So 20, right? So SOHCAHTOA and the Pythagorean theorem um, works really well in a right angle triangle, or a right triangle, I guess. And again, for you to use the Pythagorean theorem, I guess the key takeaway is Pythagorean theorem will only work when two of the sides in your right triangle are given. Okay, it doesn't matter which one. If you know what A and B are, then you can solve for C. Or if you know A and C, then you can solve for B, and so on and so forth. Okay, SOHCAHTOA works when you know one of the sides and an angle. Okay, so you need to know the angle and one of the sides. Then you can use SOHCAHTOA. Okay, and you can figure out any side, any angle inside that triangle using the correct ratio. Okay, so sometimes maybe tan might make more sense than sine. It really depends on the information that you're given. Okay, so this is kind of like a summary of grade 10. Sorry it took me a while. Um, so now let's proceed to the sine law. Okay, so the sine law is what you're going to do in grade 11, and there's also the cosine law, which we're going to cover next class. Okay, so um, again, you can read the definition. Okay, I'm just going to concentrate on the formula. Okay, um, so whenever you have a triangle, right, so the corners of the triangle will always have capital letters, and you can assign the letters arbitrarily. Okay, so they have chosen this to be A. You could have chosen this to be A. Okay, it doesn't really matter as long as you have A, B, and C. Okay, and you can pick any letters for that matter. But once you define the corners, right, what you have to be very careful with is if this is angle A, then side A will always have to be opposite to that angle, okay? So as you can see, the small a represents side, big A will represent your angle, okay? So, and that is true for every angle. So if this is angle B, then side B, right? This small b is your side length, will always be opposite to that angle, okay? And same thing for C, okay? So that's one thing that you really have to wrap your mind around, okay? So it doesn't matter where you place A, B, and C. Once you do, be consistent. Okay, so um, they have to be opposite. Okay, so if this is angle C, then side C will be opposite to that angle. Okay, now how does this work? So this sine law, some of you might be seeing two equal signs, so you might be a little bit intimidated. But what this tells you is that if you know so this works for any triangle, okay? So doesn't it see it says any triangle. This is the key piece of information. Doesn't have to be a right triangle, okay? So if you know an angle and the side opposite to it, okay? So let's say if you know this information and you know what small a is, okay? You need these two ratios, okay? So an angle and the side opposite to it plus something else, either another angle, okay? Or another side, then you can use this law. Okay, what do I mean by that? We're going to do examples and hopefully that will make sense. Okay, so once you have a ratio, you always need to have one angle and the side opposite to it. Only then it will work, plus something else. That something else could be another side or an angle, okay? But you need a side and an angle opposite to that, okay? Doesn't have to be A, could be angle B and side B. So if you know angle B and side B, then you're going to use this ratio. B is equals to sine B, because you know what B is, you know what sine B is, okay? And let's see if you need to figure out what side C is. Okay, you don't know what that is, but you know um, the angle C. Then you're gonna use sine C over so, okay, you have to be consistent, right? So if you're putting your side lengths on top, then your angles will go underneath, okay? Or you could put the angles on top, then your side lengths will go underneath, okay? But if the angle is on top in one of your ratios, then it has to be on top for each one of them, okay? So you pick whichever formula you want to use, but just be consistent with it, okay? And this will hopefully make more sense when we do some examples, okay? Um, so yeah, so yeah, you need an angle and a side opposite to it plus something else and it will work. Okay, so let's go to the first question. It's a long one. So I'm not going to bore you with the details. What the question is asking you is to figure out what this length is. Okay, so what this length is. So if this is angle B, right, then my side opposite to the angle has to be side B, right? So we're going to use small b for side. Um, this triangle is already defined for you, so we're going to have to be consistent with the picture that they've drawn for us. Okay, so if this is A, then this has to be small a, okay? And if this is angle C, then this has to be your side small c, okay? So now let's see how can we figure out what B is. I said that for this to work, you need a side and an angle opposite to it. Okay, so let's see if we are given that information. So we know this side, 1.8. And for you to apply this formula, you need to know what the angle opposite to that is, but we're missing that information, right? It's not given to us directly. However, we can figure out what this angle is because remember, in a triangle, when you know two of the three angles, then you can calculate the third one by just subtracting those two angles from 180, right? Because the sum of the interior angles inside a triangle has to be 180. So angle C will just equals to 180, right? 180 is the total um, it's like the sum of all the interior angles inside a triangle, right? So you just have to remove 88 from it, and you have to remove 61, okay? Some students like to add 88 and 61 and then remove it. It's the same thing, okay? So when you do that, you're gonna get 180 minus 88 minus 61. It's 31 degrees, okay? So remember, for you to use this formula, you need to know um, the side, there's only one side that's given, okay? It's this one. The other ones, I don't know what they are. So I need this angle. If I don't have this angle, I cannot apply the formula, okay? I need a side and an angle opposite to that side. And now I do, okay? I know that this angle is actually 31, okay? So I'm going to use this ratio. So I like to put so let's just go back to the formula, right? I am going to start off with this ratio because I know side C and angle C. So I'm going to write that down, okay? So um, I know what C is, I know what angle C is. So, okay, is equals to, what am I looking for? I am looking for B, okay? So I'm going to put a different color for B just to show you that I actually currently don't know what B is. But what I do know is the angle opposite, because if you put B up here, then this obviously has to be sine B, right? But you have to make sure that, do you know the angle opposite to side B? Yes, you do. It's 88, okay? So I know what C is. I know angle C. I know angle B. I only have one unknown, okay? So I can solve for this. So how would you solve for this? Just plug in the values, right? So C is equals to 1.8. Sine of angle C is 31 is equals to B over sine angle B is 88, okay? And now just use cross multiplication, okay? So you're gonna multiply this and then you're gonna multiply that, okay? So that means B, so maybe let's just be consistent with the colors, right? So B times sine of 30, so I'm gonna again do this in red. So B times sine of 31 is equals to 1.8 times sine of 88, okay? Now, you can change the sign values to decimal from the get-go if you want, right? And deal with the decimals. I'm just gonna, treat sine of an angle just like a number. So to solve for b, right, it's b times sine of 31, then I need to divide this by sine of 31 on both sides, right? So if I divide this by sine of 31 now, sine of 31, then this will just cancel, okay? So if you use your calculator, then b, so the final answer I'm going to just write over here. So if you use a calculator, right, so crunch in 1.8 times sine of 88, right, equals, and then divide that by sine of 31, okay? You're going to get something close to 3.49. And because the sides were given in kilometers, that means that that distance is actually 3.49 kilometers, okay? Now, one thing that I'm going to point out is if you go back to the original picture, okay, something to keep in mind. So we knew what angle C was, right? So angle C was actually 31 degrees, okay? Now, we knew what angle C was and we knew side C, so this is the ratio that we used. And then using angle B, we were able to figure out what the side length B was, okay? Now, because you see angle B is 88, right? It's bigger than 31, right? So side length B will also be bigger than side length C, okay? So if, right, because this angle C determines how big the side will be. So if this is 31, the side opposite to that, let's say, in this case, it's 1.8 kilometers. But because angle B is bigger, it's 88, then side length B, which is opposite to that angle, has to be bigger because this angle is bigger. And that is the case, as you can see. Okay, so that's something to keep in mind to kind of like check your work if you're on the right track. Okay, so if this angle is bigger, then this side has to be bigger um, than the side that was opposite to this angle, okay? Because this angle was smaller. Okay, so that's, I guess, one way to kind of like check that you're on the right track. So let's do a few more examples, right? Again, this formula, there's three ratios over here. You decide which ratio will work for you. Okay, so you don't have to use all three of them. You're only going to be using two of them. So either these two, right? If that's the way the question is set up, or you could use um, these two, or you might have to use, you might have to ignore the middle term and compare this one to that one, okay? It really depends on the question, okay? So how do you know what ratio you will use? Like I said, you need to know the angle and the side opposite to that angle. Once you have that information, use that ratio. In our case, I think it was C and sine C, right? Yeah. So once you have this information, you know that you're going to start with this piece of information and then go with whatever is given to you. If B is given to you, then you can find angle B, right? But But if if sine A is given to you, let's say, then you can find side length A, okay? So it really depends on the question, okay? So let's do one more example and hopefully this will make more sense. So if the triangle is not given to you, you can just draw it out, and just draw however you want to draw it, I guess. I like to just draw something very similar to a right angle triangle, right? Just something like this, let's just say. And then you know that the triangle has corners P, Q, and R. So let's just label them. So let's say this is P, this is Q, and this is R. So if this is Q, right? If this is angle Q, then my side length Q will have to be on the opposite side, right? If this is P, or if this is angle P, then my side lengths will be on the opposite side of that angle. And if this is angle R, then this one will have to be on the opposite side, okay? So that's something that you have to be consistent with, okay? Once you label your corners, then you have to make sure that, your opposite, the angle and the side opposite to that are matching, okay? If not, this formula will not work, okay? So you have to set up your triangle this way. And again, you draw your triangle however you want, right? If you chose this to be Q, then it doesn't matter, okay? As long as if this is your Q, then this has to be small q, okay? So you have to be consistent with um, your the way you choose to draw your picture. So what do we know? We know that angle P is 36, okay, degrees. We know that side length P is 24.8 meters. And we know that Q is, so we know that Q is equals to 23.4 meters. And they are asking us to determine angle R. Okay, so they are asking us to determine angle R, this one. Okay, so let me change the color. So they're asking us to find this angle over here. So we have an angle and we have a side opposite to that angle, right? So, so we're just gonna change the formula. So P over sine P is equals to, now they are asking me to find this angle, but I don't know what the side opposite to that is. So I don't have this information and I don't know what the angle is. So I cannot find angle R just yet. I'm gonna have to find angle Q first. Why Q? Because I know the side length of Q, right? Here, if I put, let's say if I put R over sine of R, then I will have two unknowns. I don't know what R is, I don't know what sine of R is. It's not gonna work, okay? I do know what this is, so this is a good starting point. So can't really do that, okay? So you're gonna have to do this in two steps. So let's erase this and let's focus on Q because Q will work. Now, I don't know what angle Q is, but I do know what side length Q is. So Q, I know, right? It's 23.4 and it looks pretty bad. So let me just rewrite this. And if you want, you could put the equal signs, right? If you can say that P is equals to that, Q is equals to 23.4. If it really bothers you, it doesn't matter. So I know what Q is. So I have all the information that I need because now, let me use a different color. So sine of Q is the only unknown that I have and I can solve for it. Okay, so let's multiply, okay, let's put in the information that we have. So I know that P is equals to 24.8, right? This P over here from here. Sine of angle P is 36 is equals to Q, which is 23.4 over sine of Q. Okay, so again, you're gonna just have to cross multiply. So when you do that, you're gonna get um, again, your algebra skills needs to be a little bit on point over here. So sine of q, right, times, if you want, times 24.8 is equals to um, 23.4, right? 23.4 times sine of 36, right? So my goal is to isolate for sine of q. That means I need to get rid of this 24.8, right? So because it's multiplication, I can get rid of that by dividing, okay? So I'm going to divide by 24.8, 24.8 on both sides. Then this will leave me with sine q. So sine q will equals to, so let's multiply this out. 23.4 times sine of 36, and then you divide that by 24.8. You're gonna get 0. I'm just gonna keep a lot of digits, okay? So let's just say 0.5546. Now I'm not done because I'm not interested in sine q. I'm actually interested in the angle q. Okay, so how can you find the angle? Just take sine inverse. Okay, so um, kind of running out of space because I like to write really big, but from here, let's just go up here. Okay, so angle q will just equals to sine inverse of whatever I have up here. So sine inverse of, just going to open my brackets, 0.5546, okay? And this will give me the angle approximately. So sine inverse of 0.5546 gives me, um, so they're asking me to the nearest degree. So let's just say this is 34 degrees, but I'm not done, guys, right? So 34 degrees is this. This is 34. And let's see if it actually makes sense. So if this is 34 and this is 36, then the side opposite 34 has to be smaller, but not by that much. As you can see, 23.4 is slightly smaller than 24.8, as it should be, okay, because this angle is smaller. So that means I'm on the right track, but I'm not fully done because now I have to calculate um, my angle R. But I know that this is 36, right? This is 34. So it's just a question of removing them from 180, okay? So maybe let's just erase this to make a little bit more space. I'm just going to move the R over. So angle, let me use a different color now. So angle, let's say purple. So angle R will just equals to 180 minus, so let's add the two angles up, right? 36 plus 34. 36 plus 34 is 70. So this is 110 degrees. Okay, so this is your final answer. So sometimes, as you can see, guys, you cannot find the answer directly. So you're gonna have to use a different ratio. You're gonna have to find a different angle first. But because we're working with triangles, right? Once you have two of the three angles, you can find the third one very easily. Okay. Um, So let's move on to the next question. So I'm going to ask you to do this question. So you have triangle LMN, and they're asking you to determine the angle n to the nearest degree. Okay, so work this out. Again, draw your triangle however you want to draw it. I'm going to ask you to pause, try this out, and then I'm going to do this. Okay, so pause the video. So like I said, I like to draw triangles, that has a straight base, and then that kind of looks like a right angle triangle. So let's just say that this is L, this is M, this is N. You know what? How much space do I have? So Okay, yeah, I'm gonna actually draw this triangle, a smaller triangle this time, so that I can have enough space, okay? So let's say this is L, this is M, and this is N. So if this is angle M, then this has to be side M. If this is L, then this has to be side L. And this is N, then this has to be side N. So what do I know? I know that L is 64 degrees. I know that small L is 25.2. So we have our ratio, right? We have this angle and we have the side opposite to it. So this is the ratio that we're going to be using, okay? What else do I know? I know that small m is equals to 16.5, and they are asking me to calculate angle n. Okay, so it's exactly like the previous question. I cannot calculate n directly because I don't know what small n is. So if I use the ratio n over sine of n, I'm going to have two unknowns. Okay, so because I know what small m is, let's figure out what angle m is first. Once we have that angle, then we're going to have two of the three angles inside this triangle, and then we can solve for the third angle. Okay, so let's set up our equation. So L over sine of L is equals to m over sine of m. Okay, I know everything here, right? I know L, I know sine of L, I know small. The only thing that I don't know is what I've written in blue. Okay, so remember this is not 1. Okay, so this is L. So maybe let me write it this way. So when you cross multiply, so okay, let's fill in the information. So then small L is actually equals to 25.2. Right? Sine of my angle L is 64, and this is equals to small m, which is 16.5, and then sine of m. So as you can see, 25.2 is bigger than 16.5, right? So 64 will have to be the bigger angle. M, when I solve everything, m will be less than 64. Okay, so let's multiply this out. So if I multiply this, I'm gonna get sine of m times 25.2, so this times, is equals to 16.5, right? 16.5 times sine of 64, okay? And then, right, I need to solve for sine of m. That means I need to get rid of this guy. And algebra tells me to do the opposite, right? So let's divide by 25.2 on both sides, 25.2. So this will cancel out. And then you're going to get sine of m is equals to, so let's do 16.5 times sine of 64 equals, and then you divide this by 25.2 equals, so you should get 0.5885, let's just say, okay? So I'm just using 4 digits just to be more precise. You don't have to do that, but would be a wise thing to do. So if sine of m is this, then m will just equals to sine inverse of that decimal, okay, which is 0.5885, okay? So this angle will equal to, because it's to the nearest degree, so sine inverse of 0.5885 is equals to 36. Okay, so 36 degrees. And as you can see, like I said, 36 is less than 64 because 16 is less than 25.2. Okay, so that's one thing that I like about sine law. It's not proportional, but um, it kind of makes sense. Okay, so proportional would mean that, if the angle is twice, so if this was let's say sine of 32, and this is sine of 64. If I use the word proportional, then that means that this side has to be exactly half. So it's not proportional, but it does make somewhat sense, okay? But you see, I'm not interested in this 36, right? What I'm interested in is angle N, which will just equals to 180 minus um, 36 plus 64. Okay, so 36 plus 64 is 100. So this will have to equals to 80 degrees, okay? So hopefully this kind of made sense, okay? It's just a question of finding the right ratio. So always start with the angle, the ratio of an angle and a side if you know both of them. So I started with L over sine of L because I know what small l is. I know what my angle L is. So this is my starting point, okay? And then um, the second ratio, make sure that you know one of the terms in your second ratio. Here I knew what small m was, so I could have, that means that I only have one unknown, right? So I could have easily, well, I was able to easily solve for angle M here, but I wasn't really interested in angle M. I was interested in angle N, but because it's a triangle, it's very easy to know what angle N is when you know two of the three angles, okay? So just do 180 minus the sum of the other two angles, okay? So yeah, so just what you need to do now is, I guess, practice a little bit. So I'm not giving you a lot of homework. Just do these four questions. Um, and tomorrow we'll talk about cosine law, okay? Okay, guys, thank you so much.